Welcome to this Architecture Today webinar with program partners Schu, Modern Methods of Construction, Constraint or Opportunity. Our panel of experts includes Tom Lewith of TDO Architecture, Sasha Bhavan from Knox Bhavan Architects, Jonathan Green from BlokBuild, and Eva McNamara of Expedition Engineering. In a moment, your chair, Ruth Slavid. But first, let's get started with Schu UK's Commercial Director, Sean Butler.
Welcome to the latest in our series of 80 Schu webinars. You are about to hear from our four experts who will explore how modular construction, off-site and on-site manufacturing, and design for manufacture and assembly DfMA can offer us opportunities to rethink how we design and build. The presentations will cover the latest innovations in MMC and discuss the potential benefits for cost and time savings in designing construction and the opportunities it provides to meet zero carbon targets when compared to traditional build methods. At Schu, we believe we can make an effective contribution to developing and implementing effective measures for CO2 reduction with our energy efficient system solutions for windows, doors and facades that are adapted to changes in the climate. As a successful business in the construction market, we have a responsibility for driving changes forward. We believe sustainability means designing, constructing and operating a property in such a way that it is ecologically, economically and socially future-proof, and we're fully committed at Schu to providing outstanding product and solutions for sustainable buildings. I think today's presentation and discussions will raise many crucial issues for all those interested in the challenges, constraints and opportunities for modular and DfMA. Thank you once again for joining us. I'll now pass you to Ruth, who's chairing today's event.
Thank you, Sean. I know this is going to be a really interesting set of presentations. The government defines 7 different forms of modern methods of construction, MMC, and we're certainly going to see at least 3 of them. I haven't actually worked out what fits in where, but what I do know is that this is a very diverse set of presentations, which will give us a sense of how diverse the subject is. So we are going to see some volumetric houses. We are going to see some very bespoke off-site manufacture. And we are also going to see a pioneering project for rail bridges, which has implications way beyond that. So before I introduce our first speaker, I just want to remind everybody watching this that one of the things that makes these webinars so strong is that we have such interesting questions from the people who are watching them. And there will be opportunities for me to put your questions to our speakers, both individually after they speak, and at the end there will be a group discussion. But please do send those questions in so that I can put them to the speakers. That's where we are now. And I think all we need to do is introduce the first speaker. I'm delighted to say that he is Tom Lewith, who is co-founder of TDO. Tom.
Thanks, Ruth. So TDO Architecture is an architecture studio in Suffolk in London. Our work focuses on contemporary additions to historic settings and off-site manufactured homes, although we work across lots of different sectors. So Fab House, which you can see on the left here, is one of those off-site manufactured homes that we designed and completed in 2018. And we've worked on a broad range of other projects that fall into different categories of MMC. So on the screen here is there's a modular apartment scheme and a gallery we built on the rooftop, which is repurposed water storage tanks, which are all off-site manufacturing made on site, but a very different sort of off-site manufacture. So MMC broadly falls into 7 different categories. It's considered to fall into 7 different categories. So volumetric modular is category 1, so fully factory built modules. And then as we move through the categories, the process moves away from a sort of purely off-site environment to different sort of types of manufacturing and construction, which brings different opportunities and constraints through how they're made. So Fab House is a fully volumetric modular house type, designed to be completely factory made with only the on-site necessities of foundations, utilities, service connections, and so on site. And some of the advantages I'll run through now of modular, which we discovered as we were designing it, we were able to take advantage of. And then there's also some disadvantages of modular, which I'll come to subsequently, which lead to some clients considering, or some developers considering, other MMC routes. So some of the advantages of modular, there's a significant reduction in waste with a factory built approach. There's access to labour where there may not be on an on-site environment. If you've got a factory which is, let's say, in the Midlands, and you've got a building site which is in the southeast, you can take advantage of labour availability in different parts of the country. The quality is extremely high. The precision engineering allows for airtight, really well insulated, properly considered and put together fabric, which is much harder to achieve in an on-site environment. It's a safer work environment, and the health and safety achievement in the factory environment is significantly better than an on-site one. And in general, the buildings are much higher performing. So there's lots of there's some real benefits to modular housing in terms of its direct sort of comparison to on-site construction. There's also, in design terms, we found there was a lot of opportunity as well. So when we came to design Fab House, we looked at these and explored the process and how the process could actually inform the design. So there is historically possibly an image problem with modular housing, which led some manufacturers to approach it in a way that they'll say that their houses are as good as conventional builds, and then deliver them in a way that they look as close as possible to what you might sort of call a traditional build. Our view has always been that factory built housing and modular housing is significantly better than conventional construction, and we sort of celebrate that and not be apologetic about the fact that these are modular homes, but really celebrate that. So we did that through really understanding and getting under the surface of the system. This is the interior of Fab House. So we spent a long time before we got to the point of actually producing a design, in understanding the systems and the factory and the process, learning from previous developments by the same developers and also by the same factory, and then starting to see what those opportunities look like. So in Fab House here, you can see what we looked at was exposing the ceiling joists, which is possible because the modules, when they sit down together, you have a ceiling cassette and a floor cassette which sit on top of one another. And once they're installed, the ceiling cassette of the lower module is not really doing as much work as it is in transport, let's say. So we were able to remove the ceilings and expose those the timber structure, which increased the sense of height and space inside those rooms, but also exposed all this wonderful detail. So all this timber is precision engineered, as I mentioned before. So you get very, very fine sort of tolerances and beautiful alignment and detail in the fabric, which is there anyway. So we sought to uncover that and really celebrate how beautifully and carefully made this fabric is, which is only really possible because of the fact that it's modular, because we didn't need to create acoustic separation in the ceiling here. It was done in the floor and the cassette above. And that precision engineering comes through to all the fabric that goes into the building. So you can see here the staircases, we were able to reveal the fabric that it was made out of. So it's a timber stair, but we didn't need to cover it up. We didn't need to finish it or use lots of mastic to sort of conceal construction tolerance in how it's put together. So it's all on show down to the sort of millimeter perfect fabrication that was achievable in the factory. And that comes down to all of the junctions. So we tried to explore what those junctions look like. So you can see here we've got an arrangement where throughout the build, actually, we try to avoid four corners meeting. So we only have two corners and a surface. So we have lots of sort of T-junctions in those surfaces and alignments between materials, which creates these sort of really neat junctions throughout the build. Elevation on the outside. So we were looking at this perception of modular buildings feeling lightweight and temporary. And we addressed that through very deep reveals. So the facade is actually quite deep, as you can see here in the window reveals. And that generated a bit more of a sense of permanence and weight to the building, and used a darker grey cementitious board that for the cladding, which gave it a bit of a stone-like quality and a heavier kind of more permanent presence. And we were able to use Core 10 at ground floor, which was a direct reference to the site's historical industrial use. So there was an opportunity there to introduce material that it could be different on different sites, but on this site it was allowed to be Core 10, which meant that the buildings had a direct connection to their history. So another issue often with modular housing is that it can feel a little bit sort of parachuted in without reference to its context. So we saw this material treatment at ground as being something which we could start to explore that historic connection to the site that it sits within. And then there's the deep reveals which you can see through Core 10 here. It also meant that we could address some of the other constraints of modular, which is or opportunities, which is that ideally, given that you're taking advantage of the factory environment, you want everything to be completed in the factory, and when it is delivered to site, that you minimise follow-on trades. So our design here incorporated all the services connections and everything that needed to be connected when it landed on site to the within that depth of facade. So we were able to essentially design it in such a way that the door could be locked and you wouldn't require follow-on trays to come in and connect water and electricity connections into the building. And yeah, so here's some of that Core 10 detailing that I mentioned before, and how it can start to weather on site was one of the things we looked at. So these Core 10 elements were not pre-patinated; they were allowed to rust on site. So they picked up some of the sort of weathering detail that occurred as a result of the actual location they were sat in. Where the two modules came together, we looked at using a different material treatment. So we've got the same material itself, but the treatment of it is different. So we've got ribbed finish on the where the two modules connect and they're zipped up, and that creates a horizontal banding across the site to sort of balance with the vertical rhythm of the buildings. And you can see here again how we've avoided four corners meeting. So we've got central alignments throughout the building, but also then where those corners meet, the panels don't have four corners meeting. We have two or three. So these are all moves that we took as we sort of learned about tolerance and opportunity in factory-made housing. There are challenges that come with modular, which lead to various different sort of jumping off points, as it were, as projects progress. So we found with other clients that actually the ambition to sort of work with modular is there from the outset for a lot of clients and a lot of sites. Sometimes that ambition then can't be translated, or it's better not to be translated into how the buildings are built. And there's various different reasons for that. So we found that procurement's often an issue. If let's say the best way to take advantage of modular manufacturers to work with them from the very outset of the project, very earliest stages, so you're designing to how the factory process is going to work. We found that manufacturers have different approaches, so the factory setup's slightly different, and the way they do things is slightly different. So that's one of the reasons why it's good to engage them early, but it also generates a situation where it's quite hard to achieve a fully competitive tendering environment when you get towards stage 3, 4, simply because other tenderers will have a different way of doing things, and there's the potential for abortive work, or just that it can't be openly tendered. So there's a cost risk associated with that, going that route, and also just a difficulty in achieving true sort of competitive tendering. Partly also because a manufacturer will want some sort of payment or contract for that early stage work, so potential for abortive work there as well. We've also found that order size is an issue. So to get the efficiency out of modular, you need to be really putting quite a lot through the factory. But like as any factory, there's efficiencies that comes with scale, and there's a limit to how many developers or sites will actually be able to put an order in for the sort of numbers that generate those efficiencies. In our experience, there's a limited contractor pool of main contractors who will be prepared to deliver as the main contractor, with a modular manufacturer doing actually most of the work in terms of producing the houses. And then outside of the sort of procurement side, there's limitations on the design as well, which we find quite exciting. But as you know, working with an envelope a design envelope and constraints is quite an exciting space to work in. But it does dimensionally limit what's possible to basically the sort of logistics of the road network. So you get this very temporary moment in the building's life where it's being transported on the roads that determines a lot of its future long-term volumes in spaces that are getting generated. So there's a sort of constraint there that may be something that kind of compromises what can be delivered on the site. And also, if there are doubling up of floor cassettes in a timber frame like this, then there's a limit to, well, it kind of compounds. It goes up and the building gets taller than it would be if it weren't modular. So there's lots of sort of consequences of choosing modular as a route that kind of generate these jumping off points to other MMC methods. So we're finding that a lot of clients will look at panelized or hybrid MMC solutions that unlocks a lot of these challenges. We've had clients who come to us with very open mind and say, look, I'm considering what MMC route I should take, and we'll consider the opportunities and constraints of the site and then determine what that MMC route might look like, what that system might look like. So it does generate. There are constraints in modular, but there's opportunities as well, and there's lots of ways of embracing MMC that's not modular that can actually deliver against a project's requirements. And it's important that we do consider seriously embracing MMC for the future of the industry. There's the climate crisis to address, and the opportunities that come from factory built housing really aligned with addressing it. One of the main considerations there, which we need to address as an industry, is how we can embrace mass timber within MMC and as an industry. Obviously, there are significant embodied carbon benefits to mass timber solutions, but with the current building regulations, insurance, and mortgage market, it's a challenge to integrate it meaningfully into your fabric. So if we can find a way of introducing mass timber into our MMC solutions, then the two come together to form a really compelling future for the industry that really makes a significant impact on how we can address the climate crisis.
I think that's fascinating, and it does raise some questions as well. One of them is that you talk about the need for economies of scale with volumetric housing. I just wondered, were the 2 houses of that fab scheme, the 10 houses of that fab scheme, enough in terms of economy of scale?
Well, that scheme followed on from a much larger project that was running through the factory at the time. So it borrowed a lot of the thinking and workings of that design approach. So we were able to run it through as a one-off addition, as it were, through the same factory. So you would normally, I think you'd want more than 10 homes if you were to do it as a single order, standalone sort of, if you're going to approach a factory to sort of to produce these modules for you. But yeah, we were working with a factory that was aware that this was a kind of a short order, as it were, but using the same principles as the house type that had been preceding it, and then followed it again after. Yeah, the setting up of the factory to do a certain thing and then changing it again after that causes the issue.
What about the whole life of these houses? Have you looked at how well they will function in terms of replacing elements, any potential upgrading, etc.?
There's obviously kind of some a good amount of assessment going on into their sort of longevity and so on, and they have got a kind of a very good design life. The way that the modular housing is built, depending on the system that's used, isn't actually wildly different from conventional housing. So it's more the process and the sort of availability of precision engineering and working in a controlled environment that's different from traditional housing. So there shouldn't really be that much compromise on that front. But there are issues obviously with let's say you could compare it to a Victorian house. There's a lot of structural redundancy in a Victorian house. It means you can knock it about quite easily and change things around, which you can't do so easily with modular, because you don't really know what the consequences are of chopping a bit of wall out unless you go back to the design team and work that through. So there are some compromises there, but the quality is extremely high. So it can be extremely high. So there should be some upside to contrast that as well.
And I note also that that site in North Shields is fairly flat. I think it's just got a very slight slope on it.
Mm.
How do you think this approach would work on more challenging sites, or where you were trying to create more than just a simple terrace?
Yeah, I think that's just a really good question, and I think it comes to this sort of spectrum of MMC and what that means as a strategy for building housing. So modular works really well where you've got a really good transport network, flat site, easy kind of working conditions. It works less well when you need to go into a dense city environment and you're building one or two of things which might be sort of in a very constrained and difficult site. And then it kind of suggests really the solution would be more aligned with a different MMC approach or somewhere else on that spectrum of 1 to 7. And really that's something that should be assessed at the very earliest stage, and then the right solution can be found for the client, brief, site, building use, all sorts.
You've given us a really wonderful lead into our next presentation. Just before I introduce the next speakers, I would remind everybody, do send your questions in and they will make for a really fruitful discussion, I'm sure. So next up, we have a two-hander presentation. We have Sasha Bhavan, who is Senior Partner at Knox Bhavan Architects, and she is going to be talking with Jonathan Green, who is Director of BlokBuild. So over to you, Sasha and Jonathan.
Jonathan and I are going to talk today about our collaboration, him as a constructor and us as designers. And we hope through the process of this presentation that you'll understand how important it is that designers and makers collaborate together, and through that is how we get the best result. This was the start of our collaboration, our relationship, where we knew that Jonathan had new CNC machines and would be able to cut out difficult and complicated shapes for us. And so he then did all the cutting out for our sit-down, stand-up desks, which were really quite complex. And it worked really well, and he also did all the cupboards and everything in our new office. We then collaborated with him and a very old friend of ours, Tim Lucas from Price & Myers, who works with BlokBuild as well. So the three came together and we designed this very, very slim, slender floor for the mezzanine in our office. And it's all made from prefabricated components. And maybe, Jonathan, you'd like to say a few words about it.
Yeah, this was something that was constructed as models. So we prototyped the mezzanine and installed it, and it was a perfect fit. And it was actually the first sort of time where we talked about the system that we've been developing with Price & Myers as a building system. And I think we started a conversation about how that could be used in projects with Knox Bhavan.
So this was Jonathan and BlokBuild's components coming together very sweetly on site, and the floor has stood up very well. It's a bit bouncy, but that's testing the limits. Jonathan, this was the first time you'd started talking to us about the BlokBuild process, and you sort of introduced it to us as a possibility of us working with you on something.
Yeah, I think we had a prototype in the car and brought that out and were talking to Simon about how that could be used in future projects.
And this is the final result, looking very elegant in our studio. So moving on, we're going to just briefly talk about three projects. The one on the left is March House, which is a project that we finished mid-COVID. And the one in the middle is a project which is nearing completion. And the one on the right is a project that BlokBuild have just invited us to collaborate with them on in Bristol. So quickly moving on to March House, extraordinary site right by the River Thames, and very susceptible to flooding. So we had to take that into account from the onset. And we had in our minds that we wanted to work with BlokBuild on a project, and this seemed like, you know, the perfect project because of this lifting up, and because it was very difficult site access. Beautiful site, you can see here, but you see the site outlined in red. That's a very narrow little track that was only opened in the 1960s. Before that, all the houses were built from the river. So difficult access, needed to be done quickly because of the risk of flooding. And so we thought, oh, let's go and have a talk to BlokBuild. So here you can see the house, the various flood levels, and it's lifted right above it in the section on the bottom right. The plan is top left, and the AXO is beginning to show the BlokBuild system being used in the project. So to begin with, there were just some piles put in, and then we built this deck, and this was all with Price Myers, with Tim Lucas. We designed this very elegant galvanized deck, which went in quite sweetly, and we had a crane on site anyway, so the crane was perfect for BlokBuild.
Yeah, so the cassettes arrived on site, and we sequenced these in the workshop. So these were a hybrid between sort of digitally manufactured cassettes and more sort of traditionally built larger floor cassettes. They were sequenced, so they were like taken off the lorry, installed onto the steel with an underlap and an overlap. And we actually, in installing these, we realized they were a little bit too large. So we brought that kind of information into how we were going to build the roof cassettes and the wall cassettes, and we split them. So at this point, we were still manufacturing the roof. So that informed us to make slightly smaller cassettes when we came to the roof. This is a picture of them going in, and you can see how sort of precision it is, where the crane operator is craning them in, and they've got this underlapping and overlapping skin on the top and bottom. This is an example of an exploded view of the wall cassette. So you can see that there's no additional structure within the cassettes. They're pre-insulated, and they're assembled off-site. And this is a little bit of detail. So on each cassette, there's a unique reference and a peg slot. I'll go into a little bit about what that's for. This is showing the sort of manufacturing process and assembly process that we go through, and the efficiencies of our sheet usage and nesting on the CNC. So the peg slots within the cassettes, as you push the cassettes up to one another for the wall cassettes, we put these plywood tapered pegs in, and they locate the cassettes whilst you're installing, which keeps them quite sturdy on site. And then on the right hand side image, that's a structural lintel. So there's no need for any additional structure within the lintels for the openings or windows or the doors. We just use these OSB ribs, which run horizontally through the lintel cassettes. It's an example of a wall elevation with the peg slots. As you can see, that's just before the pegs have gone in. The pegs go in, and then the nail plates are put over there. They're a Simpson strong tie nail plate, and they're part of the engineering package, and we'll talk about that a little bit later on, because you can see these ones sit proud over the peg slots. And on the left here, this is the cassette arrangement for walls as they arrive to site, similarly to the floor cassettes and the roof cassettes. They've all got their unique reference numbers on, and they're dropped in the location in which they're being installed.
And this is where you're beginning to see how the views are being framed and the house is going up. And from our point of view, that's really helpful because it means that the client very early on can go in and see what the view's going to be like from her bedroom and what the spaces feel like. And that's really such a bonus. And then you get a happy client on the right and a happy team on the left. And this is about the construction and the speed of construction. And I think overall, from the time of the first floor plate going in to the last roof cassette going in, it was about 4 weeks, wasn't it, Jonathan?
Yeah.
But you can see also it's just interesting the way this house is floating over the ground on this deck, and here it is, gradually coming up. So this is about putting into the system the more refined and machined elements, such as the walls and doors and the cladding on the outside. And it's about tolerances, really, because we're learning all the time about tolerances. But what happened was these nail plates that we've mentioned a couple of times already became a burden because we had to go over the top of the nail plates, and it created a lot of work with battening and so that was something that BlokBuild were able to take away and think about for the future. But generally, the system worked really well for us to help us achieve beautiful details and kind of coordinate things very well. There's not a cut board in the house. Everything runs through, and they're very simple materials, but we're able to coordinate them very well. And as you can see, it gives you a very beautiful house, lovely big openings with those cassettes forming the openings. And I thought I'd just put this in to show you that there is a reason why the house is lifted off the ground. And this was from our client, her first season in there, and she was thrilled. She felt it's all worthwhile. And now the building is well embedded into the landscape, very fast. It all happened. So this is the second project we're going to show you, which is one that's on site at the moment, nearing completion. This is the render of it, CGI early on. This is for a client called Henry Fraser, who's a remarkable young man. He was paralysed at the age of 17, and he has become very well known as a mouth artist and as a motivational speaker. And it's a house, he's now 27, and it's a house for him and to give him independence. Anyway, as you can see on the right, it's a restricted access. So again, and it needs to be quick because the neighbours didn't want people going up and down the drive. So again, this became a system that we thought would be good. So these are the Vectorworks 2D version of the drawings out of BIM, and these are what you'd expect to see, construction drawings, but already we're thinking about the BlokBuild process, how we can include it. And here's our 3D BIM model. And then we turned that into a Rhino model. Fergus has been working on this very closely with Jonathan. And he turned it into a Rhino model, which then enabled Jonathan to...
It enables us to create our production model. So this is the production model for manufacture, and we submit this model to Knox Bhavan for approvals. So in the approval process, the as-built kind of cassettes or fabrication model goes back off, or the elements that we were designing and engineering goes back to Knox Bhavan. we have status A and status B for production, and that enables us to put things into manufacture, but working really closely for dimensional sign-offs and approvals.
And we worked with this on this project with Structural Workshop as the kind of project architect, engineer, and then of course Price and Myers, Tim Lucas as Jonathan BlokBuild's engineer, and that was you know, we got the best of both worlds that way. And these are more of those sign-off drawings, aren't they?
Yeah.
Elemental drawings.
This slide shows how we sort of brought in the learning from March House and brought that into Scatdale Lane with the rebated nail plate positions. So as Sasha was saying, where there was the integration with the battening and tolerances, we kind of decided to rebate these, which serves two purposes. One, so that we make sure we take up that room for human error, and we know that where the nail plates are needed for structural kind of certainty, that they're going to be positioned, and then it gives a flush internal and external face. They go over where the plywood pegs slot in as well. This shows on Scatdale the structural pattern of the nail plates. You can see it's all been filled, so the rebates have worked. And then on the next image, there's a cassette arrangement with holes in the top, and the holes are for hand holes for access for bolted connections. So here you can see a unsupported roof cassette going in, which relies on these bolted connections between cassette to cassette, and these hand holes enable access so you can get the bolt in and tighten those up.
And what the system also does for us is it allows us to work on the architectural elements, i.e. weathering and the kind of detail of shading, and you know, all the things that we need to make are happening on the outside of the building. And what happens here is we've got these cassettes made up to go on the outside, and they're not filled with insulation, so there's no wastage there. And these, as you can see here, we're beginning to play with the kind of geometries and think, oh, what could we do with this? Because what does it offer us, really? And it offers us quite a lot. Amongst other things, a nice clean interior and a nice clean exterior to get going on both things at the same time. So again, speeding things up. Here you can see that the cladding was a much simpler exercise on this project because of those nail plates. And again, it enables us to have very simple detailing, and it's looking quite fine at the moment, moving towards completion. And you can see how we're making the most of these geometries in the eaves details. And here's just a few quick fly-throughs to show you just how easy it is to work in there. All dry, all cleaned up, all ready for the joinery to go in practically, paint and joinery. Here's the house nearly finished. And we had a webcam up the whole time so that Henry could see what was going on from his house, because obviously he was isolating all through the last couple of years. And then finally, we're very quickly going to take you through the We Can Make project.
It's a project where we're working on at the moment, and we've introduced Knox Bhavan to working with We Can Make, which is a community land trust and part of the KWMC family. We're on site at the moment with two microsites. They're their pilot scheme, and Knox Bhavan have come in to have a look at the three typologies of sites that we might be looking at in the future.
So those three typologies are, these are the microsites that Jonathan just mentioned, which are all basically back gardens in council houses, or little bits of leftover land between council houses. And it's about making, you know, small interventions, and sometimes slightly larger. But what we were looking at was how we could help our collaborators to think about how to place buildings, you know, what elements to have on them, that sort of thing. And then this is the middle-sized project, which is 8, I think, flats as an infill. And then this is the final possible project, type of project, which is a much bigger house builder scheme, where BlokBuild and we would be given a few service plots to show what we could do, really. How can we do something that's maybe an improvement? And through all of this, the ambition was to have a kit of parts designed. Could we design a kit of parts that can then be used according to orientation and siting and all of that sort of thing? And we went through, for our client, we showed the process where the first part of the process is translating the sketch scheme into a priced model, price coordinated model. And then the second part is about detailed design and delivery and refinement and pricing properly of the model. And you can see here, Price and Myers start to become very involved at that point with BlokBuild. And the last bit is about fabrication and delivery. So we get this, this whole process coming through.
This is about the localizing the manufacture. So on the left, you can see that's our kind of facility in Hull. And on the pilot scheme, we've actually made a percentage of the homes in a community workshop in Bristol, the We Can Make factory. So that's the long-term goal, is to bring more of the manufacture locally to Bristol.
And that's thank you very much. And as you can see, you can get a very peaceful and beautiful result from this. Our final word is just that this works because we get on really well together and we work with each other. And when you're trying to develop something that's a new way of thinking or a new way of doing something, you absolutely need that. You don't need the kind of combative contractor relationship process going on. And we're absolutely thrilled with what we've managed to be involved in with BlokBuild.
I've got here what purports to be a question, but is actually a series of questions, which I think will use up the short time we have available. And this questioner says, how are services coordinated? How is coal bridging addressed with exposed steel? Do you know what the net zero carbon gains carbon footprint were? And what were the cost differences compared to traditional build? Maybe we should start with the last one of those. Sasha?
What we do know is that the BlokBuild system probably costs about 20% of the budget. And for us, it's at least the same as, say, a timber frame, and maybe cheaper. It's very difficult to evaluate exactly, but then there are kind of hidden benefits, which are the benefits of speed, and that really does cut a lot of the cost out. Is it Hull University, Jonathan, who've done a study?
Yeah, it's Hull University. We did a study with Hull University on the Bristol project and looked at like for like carbon comparison between traditional and our system, and it came out at 40% kind of better than traditional. in terms of carbon usage.
Well,
And
that
they
is
also
impressive.
took a typical house of about 72 square meters. I mean, this is much more interesting than hearing about what we've got to say, because this is an independent research project that Hull are doing. And the cost was 136,000, of which 22% was the cassette building, as it were. So it worked out at about £400 per square metres delivered to site. But it is very difficult to unless you take two buildings and compare them exactly. But we have done that in kind of traditional construction and block build construction, and every time we've done it, whether it's for carbon or cost, or it's come out beneficial. But speed cannot be underestimated. That, you know, all of that's money.
And just to answer on the services, we can run services through the cassette system and inside conduits, or if we're running a service cavity, we can engrave on the cassettes locations at which the services are needed to be pulled through, and that just enables and assists with follow-on trades.
Thank you. There's obviously a lot more. Oh, sorry.
Sorry, Ruth. I was just going to say, on the issue of the coal bridging, that's a good question, because what it is a steel frame that this cassette insulated box is just stuck on top. And what we found with detailing this system was it was fantastic, because we didn't have to worry about coal bridging at all. It's just like wrapping the whole thing up in a duvet. So that was hugely releasing in terms of detailing, not having to worry about nylon packers and this and that. You know, you just go, oh well, this box is all insulated, so we can just have fun and
There was also a structural timber sole plate on top of that steel platform, and then our insulated cassettes sat on top of that treated sole plate.
There's obviously a lot more to say about this, and I'm sure we'll come back to some of it right at the end. But now we are going to go on to our final speaker, who is Eva McNamara, who is an Associate Director with Expedition Engineering. Eva.
So today I'm going to talk about the fourth industrial revolution, so the AVA footbridge system for network rail footbridges and beyond. As mentioned, my name is Eva McNamara. I'm an Associate Director at Expedition Engineering, which is part of the Useful Simple Trust. The Useful Simple Trust is a family of professional design practices driving change. So we've got a bunch of talented and committed engineers, architects, designers, and strategists who work side by side. So I'm here today to talk about MMC and footbridges, although I'll say MMM, modern methods of manufacture and footbridges. And where did that all start? So Anthony Dewar, who is Network Rail's professional head of buildings and architecture, likes to show these two images when he talks about Network Rail's approach to bridges and how they haven't really changed in the last 50 odd years. So he was thinking about access for all and a good user experience, safe places to wait, and an inviting journey across the bridge. So you can see on the left there a bridge constructed in 1969 and another bridge constructed in around 2016. And really there's very little difference in the structural system or the architectural approach. So I think it's true to say that the construction industry hasn't really transformed in the way that others have, and that modern footbridges are produced in much the way they would have been in the early 1900s. Certainly health and safety has vastly improved, but many techniques haven't. So, but other industries have transformed and have been disruptive. So take Amazon, for example. The speed at which we can order and receive a delivery is astonishing, and the R&D they have in the pipeline is endless. So for the construction industry, we're hovering somewhere between industry 1.0 and 2.0, with the occasional reach towards industry 3.0 with the rise of DfMA, but we're certainly a long way off in general terms from the smart factory, automated systems and machine learning. So for Network Rail, they knew they needed to move forwards, and they did so with a bunch of new bridges in around 2020. So that's the Beacon, the Frame and the Ribbon bridges, some of which you may have seen in industry press over the last couple of years. But they all use traditional forms of construction. However, Network Rail have also invested in R&D on 2 next generation bridges, one of which is AVA, the manufactured footbridge that I'm going to talk about today, and Futura, which is an FRP footbridge. So when we talk about innovation, we often talk about disruption. And what exactly are we trying to disrupt? So, well, in 2020, for Network Rail, a typical 2-lift, 2-platform footbridge had a total project cost in the region of £3 to £4 million. So you can see that the superstructure material cost was around 17% and other costs around 83%, an enormous difference. So we knew that this model needed disrupting for a number of very good reasons. And that meant putting together a bunch of experts, both with and without rail and transport infrastructure experience. So perhaps let's call us a professional motley crew who could innovate and challenge the client. So that team is AVA, and we're made up of Walker Construction. So they are an experienced contract installer of footbridges on Network Rail, and it was really important to have that kind of strong base experience there from the contractor. Expeditions, that's us. We're an SME, and we design. We're a design and engineering consultancy, B Corp and social enterprise, and we're acting as lead designers in the engineering consultancy. We've also got Extreme Systems, who are designers and manufacturers utilising manufacturing technologies, including Digital 4.0, and Hawkins Brown, who the architects we're collaborating with, and many others there you'll see that make up that consortium. And the consortium's challenge really is to design and manufacture an innovative footbridge that challenges the design and installation of legacy standard footbridge schemes. And that co-funding from Network Rail and Innovate UK means this bridge isn't just a concept. I think that's really important. It will be built as a physical demonstrator early next year as part of the TIES Living Lab programme. So what are we trying to achieve? It isn't just about the money and the time on site, it's also all of the following. So that's delivering reliable access for all, delivering better value for the taxpayer, delivering a beautiful and timeless piece of design with a positive value for all, resetting the benchmark of industrial design possibility for the future of publicly funded products and projects. I think that's really important here. We're working on a footbridge here, but really it's an example of what you could do with manufactured infrastructure. We're respecting the climate in full through a lean start, loose fit and long life principles. And we're calibrating the project against existing benchmarks where that data exists or can be developed. And we're using this project as a case study to show how small improvements that repeat thousands of times can deliver large benefits. So the bridge. I want to show you a few rendered images of the bridge that's currently with the manufacturer, and I just also wanted to show a reminder that this is a manufactured footbridge, not fabricated. So those are some images, sorry, of the machinery that the manufacturers use, and then this is a render that Hawkins Brown have done to show how we're essentially folding stainless steel sheets to create something that is a beautiful and timeless piece of design with a positive value for all. So here's a few images, and you can see that the services are integrated into the bridge. So when we had this clean sheet of paper at the beginning of this innovation process, we had 2 access for all spatial configurations that we considered. We wanted to cover the brief and maximize the good principles of access for all, so we came up with these 2 versions. The first is a narrow configuration which minimizes the span, so that's good for carbon and land take, but it's less progressive perhaps in terms of the quality of experience for the user. The second is a wide configuration which could be used where space permits and provides a preferred user experience for all users. Keeping in mind that this is an adaptable footbridge, we wanted to make sure that these configurations could work to suit a number of different situations. And you can see here, using the same system, the number of different configurations we could end up with. So importantly, I think with an innovation project, particularly when we're stretching the boundaries of MMC and MMM, is that you need to change the heart and mind of your clients. And to change hearts and minds with Network Rail, it was deemed really important that we should build this over a live railway and go through the full grip design process to prove that there were no barriers to AVA for a speedy rollout across the network. So this prototype here, we settled on a test site in RIDC Widmerpool. So it's a test track with live trains, but has no public access. So we could keep on innovating in the spirit of the prototype whilst testing our work against the reality of the requirement of the railway. The devil is always in the detail. And just to make things more challenging for ourselves, we proposed building an asymmetric bridge to test both the narrow and the wide configuration. So of course, this maybe looks a little bit odd from an architectural or engineering perspective. Actually, it would probably fit some sites in particular, but it was in the spirit of the prototype to have the mindset of allowing value of the wide configuration to be tested relative to the uplift in cost and land needed before perhaps it would have normally been dismissed in a value engineering type process. So we need to build a bridge, but we want to do it differently. And we want to maximize the use of manufacturing principles. And this was and still is a learning curve for everyone. The manufacturers needed to show us their capabilities, and we needed to understand how to get the best out of them. And they, in turn, needed to understand a construction approach and an iterative design process. So therefore, we emphasise the importance of a prototype. And I think this is really, really important for MMC. By going through the prototype process, you learn a hell of a lot. So this was a design that we had collectively developed during the first 4 months or so of our work together back in 2020. We wanted to test accuracy, tolerances, thinness of sheet, design without welds, material efficiency, cutting from plates, the finish, the process to work hand in hand in the delivery of a design, how easy it would be to put together, how thin we could go with the sheets if we hit them with a hammer, the list goes on. And it always does when you're testing things. And here you can see an image of the prototype and the exploded kit of parts. And the translation into a manufacturing production set of drawings. Obviously, they want to nest the information as much as possible so that they have minimized wastage and therefore CO2. The prototype production process. And now I'm just going to show you a little bit of a video here. So you can see really the difference between, between visiting a kind of fabrication yard and visiting a manufacturing assembly is just, I mean, they're worlds apart, and it's really like more like a surgical operating theatre is probably a good analogy. You can see there's some automated processes going on. I'll just flick through to some other bits. See the sheets being lifted. Bending taking place, and so on. So, and there is the finished prototype with lighting tests that we also undertook. See here. Actually, sorry, I'll just go back to that one. So really, there is nothing better than a prototype for convincing a team that it can be done and in bringing the client with us. And to be honest, this was probably more a demonstration of Industry 3.0, but it allowed us to imagine that the move towards Industry 4.0 would be possible and that we could show this could be done in the construction industry. Now, another interesting part of this novel footbridge that we've come up with, and this whole project is an innovation project, one thing that stuck out to us in achieving access for all is that we rely quite a lot on lifts, of course. Lifts that are notoriously slow to commission, slow to repair, and when they're out of action, they have a big impact on the very users we're trying to modernise access for. So to speed up the time on site and cut those capital and operational costs, we knew we'd need to disrupt the current lift industry. So together with SEX Special Projects, who've worked on the retractable roof at Wimbledon and the retractable pitch and surround at Tottenham, we came up with a new lift system that would have 100% redundancy to eliminate downtime, and it could be installed as a plug and play element. That plug and play part of it's really important. And by that, I mean that the lift comes pre-commissioned, already attached to its spine, and simply plugs into a foundation. So looking at that image, you might wonder about the curved door. In fact, this is similar to the way toilet pods open on trains and are apparently many, many times more reliable than a typical lift door mechanism. So I quite like that we ended up taking that inspiration from the tray, from the rolling stock, but also something that's quite, great to have an architectural curved element that's also beneficial from a reliability perspective. So here you can see the mechanism and the drivetrain being tested. And after commissioning, it would be laid flat and transported to site, much like a washing machine, with just a few bolts to be released on installation. So these lifts could be easily retrofitted to existing footbridges with or without lifts, and used on new bridges when they aren't part of the AVA system. And I think also this could be really interesting for refurbishment of existing buildings and so on, for example, where you don't want to build dig a new massive lift pit in the middle of a building. So I think there's loads of opportunities here that where this kind of innovation in MMC could be adopted. So the next part of the story, I suppose, is the rapid site construction. So we wanted to get a system where there were minimum possessions. So that's when the railway is closed over a period over the weekend and creates a lot of disruption, which is why you want to spend as little time as possible installing these footbridges. So we would like to do that in the minimum amount of time, and ideally in line blocks, not for this first prototype, but a few down the line. We explored dry foundations, so using a steel grillage on screw piles, because this footbridge is a temporary prototype at Widmerpool. We wanted to be able to use circular economy principles to sort of leave no trace when we deconstructed it, and that it could be reused elsewhere. And that's now, for other reasons, we'll be using a different kind of foundations, but we know this system will work in other locations. It's assembled off-site, fully clad, fully bolted, very little welding, and fully pre-commissioned. So this is one of Walker Construction's jobs that they show, which is in Hampstead. And I think one of the things that they say is quite pertinent is that they'll lift the footbridge over the railway in a couple of weekend possessions, but then this construction site goes on and on, because essentially they install the lift, and then the lift comes in piecemeal parts, and it takes another few months really to get the whole system going, for the footbridge to be clad, all the parts of the lift mechanism to be put in, commissioning, and so on. So we wanted to again disrupt that, and things like that plug and play element of the lift really help with that. So here's just a little bit on the construction sequence, and you can see it going in parts. And there's that lift fully pre-commissioned and brought in on the back of the lorry and lifted into place. So all this is good, and what I've described is probably Industry 3.0. Now it's a good step forward. AVA will use manufacturing production lines and so on. But how do we move this really into the fourth industrial revolution and Industry 4.0? Well, another partner in all of this is the Manufacturing Technology Centre, the MTC, and they were commissioned to produce a configurator for this project. So this is partly to address the issue that Network Rail have with the slow start to the procurement of their bridges. For example, for any given station, what could they have? Can it fit? And what's the best configuration? Roughly how much will it cost? How long will it take? How much whole life carbon will it cost? And so on. So this will help Network Rail and others select the bridge they need. But with a few bridges under our belt, it will also hopefully be developed to spit out the manufacturing information within pre-approved parameters, and then that drastically reduces the design and production costs. So as designers, we might do ourselves out of a job, but it's all good industry progress. So this is all currently in development, but you can see the building blocks being put together to determine the best configuration and so on. And then these are the outputs that the configurator would give, all the important things that you'd want to know, like cost, service life, maintenance cycles, carbon, lead time, and so on. So these are a work in progress, but these are the results we're aiming for with the innovation process. And I think, you know, given the process we've been through, this might not be achievable for the first iteration of this footbridge, but by going through this process, we set it up to achieve it on the second, third, fourth bridge. So the lower cost, we are aiming for around a 34% reduction in capital costs. Fast delivery is 65% reduction in site time, and so on. Lower carbon emissions. So importantly here, stainless steel, although higher in embodied carbon, has almost zero maintenance associated with it. So we know in the challenging kind of maintenance requirements Network Rail have, that this bridge will certainly last 120 years, if not 200, 300, and so on. It's got better performance, so that 200% increase in service life and 100% increase in lift reliability. And it's got the core benefits of equality, access for all, it's configurable, and it's an example of UK innovation, so a next generation of rail assets. And there it is again. So the design is currently with the manufacturers, who are turning it into information appropriate for their automated systems. And this first iteration will take longer, but it sets the system up so that versions 2, 3, and 4 can be considerably quicker. These will now become the building blocks of the adaptable bridge for easy, low-cost adoption across the network. And I think that although we're looking for a footbridge here, like I said before, it's an example of the future of manufactured infrastructure. So we can apply these lessons to infrastructure, also to buildings, and so on. And of course, we've still got so much to learn from other industries, and we need to continue to incorporate development, so we are continually improving and providing value for our clients. So if you want to scan this, you can go and have a look at standing on the Ava footbridge, and then you can spend your time having a proper good look at it. And that's it from me. Thank you very much. If you've got any questions, then please feel free to email me, or we can discuss them later. Thank you.
I thought that was really interesting, as somebody who's actually been with somebody who had to miss a train because the lift down to the platform wasn't working. Has Network Rail actually got a proposed programme for construction of these bridges?
So it's really interesting. Network Rail, they're essentially a regional organisation when it comes to commissioning of their infrastructure light footbridges. So they've got a centralised team that are looking at kind of spreading the word among these regions, who can then take it up. But essentially they're kind of individual portals that we hope will come to us when we have the prototype built later in the year. We will be inviting them all to sort of increase the uptake. But yeah, they have a requirement for, I think, something like 1,000 footbridges over the next 5 years that they need to put in place. So there's a desperate need to commission fast projects like this.
And you talked about better user experience of footbridges. My experience is that a lot of footbridges are really marred by building up the sides really high, either originally or later, to stop people throwing things off them. How are you dealing with that?
So yeah, many people have made the same comment in the past about that. Network Rail, I think last year updated their, I think it's called footbridges and subway guidance, and it's much clearer about the requirements in the first place, so that people can get that design right and they can be consistent across the network. So for this, where there's overhead line electrification, you require a barrier of 1.8 meters in that zone. So we've got a parapet height and then glazing above it, so that it doesn't feel enclosed, and that we also have the opportunity, by the way that we've designed the system, to plug and play higher or lower elements in the parapets as required. So it's thinking about that adaptability and where there's different needs in different stations.
I'm going to bring our other speakers back in, as if by magic they're about to appear. But I'm still going to put my first question to Eva, because I think it then resonates with another question that we've received. So this first question is, the elephant in the room when talking about the fourth industrial revolution is people. In terms of the process, how does the new process lend to providing jobs or livelihoods when compared to more traditional methods of bridge construction?
With this job, we were really mindful about who would be building this. And actually, right from the very beginning, we defined that this needs to be built by SME businesses. So basically, when we explored with Extreme about how to make this, we ensured that it meant that thousands of different businesses across the UK could do this, and it wasn't just creating something that one specialist manufacturer could make. So this is activating, let's say, an SME part of the manufacturing industry that might not otherwise, and that was part of the Ties Living Labs aims to sort of join the SMEs up to do that. So I think there are pros and cons about, let's say, fewer people working on some of this, but we're trying to diversify where that income is coming, and that is to SMEs through this process.
And I know that when Eva was talking, she was saying with this configurator, there might be less design work as well on individual bridges. And I think that resonates with a question which we've had in from someone who says they've used a variety of MMC systems in over 25 years and that there are very few drawbacks. But they said the problem is the resistance from contractors and clients. And there's also a lack of work for architects, as most MMC manufacturers only use technicians. Why? Tom, I don't know whether you've looked at this. Obviously, you've been the architect on these initial houses, but I guess the question is, how far does an architect stay involved as the schemes continue to be rolled out?
It is a good question. I think in a more sort of in a wider sense, there's it's maybe a slightly different point to the question itself, but there has historically been a sort of reluctance to allow specialisms to sort of chip away at the role of the architect over time. And our feelings of practice is that as architects, we can offer something in particular, which if we can specialize in that area, then we can allow other people who are better qualified to do other exercises. And I mean, certainly when it comes to sort of modular or MMC in any guise in housing, we're dealing with a housing crisis, and there's a shortage of housing. So there's plenty of work to be done. I'm not completely convinced that there's less to do. I think there is it's a sort of change in process rather than as much as anything else. So designing for a process rather than designing for a given outcome. So it's probably more akin to, in procurement terms, design and build, where you are working with a manufacturer who's got their own sort of delivery side team. But yeah, in our experience, there hasn't been that much of a drop off in the amount of work we need to do. But that may also be because, as I said at the outset there, we try to focus on what we feel, where we feel add value, which is in the sort of concept and early design stages, sort of 0 to 3, which is quite well aligned with that MMC process. So really, I think it depends on what your business model is as a practice and what ownership you want over the design process.
And Sasha, obviously the houses that we've seen, you've been working incredibly closely and absolutely nobody could replace you. But it's interesting when you looked at this last project and you say you're trying to find a kit of parts which could sort of fit into, one tiny backland scheme or a larger project. Presumably going forward, if things like that pick up, does that actually affect the world for you and the opportunities that you think you have?
I think sometimes clients can think there's a magic wand and, you just design a dormer window and a front door porch and a bay window and a this, and then we can put it all together in whatever configuration we want, and we don't need you anymore. And I did actually have a conversation last week where I said to the client, we don't want there to be any camels running around here. This is about design, and it is about the kind of making a kit of parts is in order to enable design to be better for low-cost houses. And, you know, you think about the garden suburb and the sort of way that a kit of parts works in a garden suburb. That's how we're imagining we can bring something to this process. But it's absolutely not to get rid of the idea that you enrich the urban and the built world by getting rid of designers. I think designers have got, you know, obviously I would, but I do think we've got such a lot to offer.
And Jonathan, you touched on something which perhaps is one of the really biggest concerns with MMC. You did say that the sort of elements that you're making could be used to extend or refurbish an existing home. And I'm interested to know to what extent you think it can, because obviously one of the things with MMC is this wonderful idea that we can produce all these things so effectively. And actually, of course, what we really know is that as much as possible, we need to be working with existing buildings. So how broadly do you think that can be applied?
It can work either as sort of rooftop development or as extensions. So we've worked on a number of kind of additional roof buildings which have gone to flat roofs, or sort of lean-tos or extensions that integrate into the existing building.
And I think, Eva, it's interesting to hear this from you because, of course, Network Rail has an enormous estate of existing structures, existing buildings. And I don't know how many new footbridges it needs. I'm sure it's quite a lot. But nevertheless, it's interesting to see what you think you can do to address the existing estate, particularly, I suppose, with these plug and play lifts.
Yeah, I mean, just by chance, we're actually working with Network Rail now on looking at decarbonising their buildings and civils, basically, portfolio as well. And a huge amount of that is going to be about making, using circular economy principles, increasing the life of their existing stock and improving it. And I actually think, sorry, mixing a few points here, but I think at the moment, the way we're designing with MMC is really, let's say there's like some standardization associated with it, obviously. But if we think about kind of the next stage as we get even more clever with this, I think we can be bespoke as well and use the principles of MMC. And I think that's where, you know, we'll go through this journey in design as designers, architects, engineers, where, you know, we're learning about standardization now, and, you know, it's a massive learning process from getting that right and wrong sometimes. But with the next leapfrog is that we've done that, and then we learn how to be bespoke within that standardized. So I think this is a really evolving journey for all of us to, and it's so important for meeting net zero, but it's also really important to create a beautiful environment as well, and that's not just going to be standardizing everything. So yeah, I think there's so many opportunities here.
And I'm going to move on in a minute to ask a question around timber, but that's around the whole issue of embodied carbon. And I was quite interested, Eva, again, in your presentation when you said these are stainless steel bridges. They've got quite a lot of embodied carbon, but we think it's okay because they can have a lifespan of 120 years. And I wonder, has anyone actually done a study looking at the lifetime of bridges, not because of whether the structure falls apart, but how often actually they have to be replaced because the stations improve, the platforms move, etc. In other words, it's great to say, okay, we're going to put quite a bit of carbon in now, but it can last for 120 years. But what if it doesn't? Because actually there are lots of outside factors which mean that it just won't.
I mean, completely. It's such a minefield of different points there. I mean, we found that because disruption to the railway is so important to Network Rail. It's very rare that a bridge is moved because a platform needs to change, for example. It's more that the bridge hasn't been looked after due to maintenance funds or whatever. So instead of it lasting, these structures were supposed to last 60 years, they're being decommissioned after 30 years and need replacement. So I think the maintenance issue for infracos is really important. I think and every situation is unique. So with this, it's fully deconstructible as well. So in terms of circular economy principles, we know that the stainless steel doesn't corrode in the same way as mild steel, painted steel does, and so it can be taken apart and reused elsewhere. And that's definitely been a very important part of the design, is thinking about the circular economy principles from the beginning. So yeah, I mean, we have to be using as low carbon embodied carbon, upfront carbon as we can, but we also need to be mindful of knowing the client's challenges around maintenance and so on. So there's always going to be that balance, and I'm sure the answer will be right in some circumstances and not right in others, and we'll learn that as we go along as well.
And as I said, that was a slight tangent from the fact that somebody had asked a question which I think was very much aimed at Sasha, which was, you've slotted these cassettes into a steel structure. I'm sure you're going to tell me with Marsh House that steel and only steel could keep you above the floodwaters. But in more general terms, have you looked at using them with a timber structure rather than a steel structure?
It can be completely timber. It's only on the steel frame because it has to be lifted above the water. So generally, it's a timber structure, although, obviously there has to be some kind of slab. We have to deal with the issues of the ground, touching the ground. But yeah, I mean, everything, when we have those big openings, big wide windows, one of the slides showed the way in which there are timber fins in the lintel over the top. So there's no steel at all in the building. It's all timber.
And I know, Tom, you said you were interested in doing more with mass timber in the future.
Yeah.
I mean, one of the issues is obviously with the sort of cautiousness that has come post-Grenfell, which means that while there are an awful lot of things that need to be put right, there seems to be a sort of collateral which isn't doing terribly well for timber. But also, I know that one of the problems in the past with timber construction has been the wariness of insurers. And somebody's asked a question here about wariness of insurers in terms of MMC in general. So I don't know if you've got a comment on either of those, and then I'll probably go back to Sasha about that as well.
There is obviously kind of regulatory challenges at the moment using mass timber, certainly over 18 meters and potentially over 11 in time. So that's just a sort of black and white situation where we can't obviously go against that. So I think there needs to be some sort of clear thinking at government level about what that means, what our priorities are, and what sort of testing is required, and the realities of working with mass timber. It's got to be part of the solution to the crisis that we're facing. In terms of producing carbon negative or carbon neutral buildings. We can't change the regulations ourselves, so we have to sort of wait for that to happen or hope that it happens. In terms of the insurers, there's different. Obviously, there's lots of different stakeholders in any building project and different insurers as well. So professional indemnity insurance, or there's insurers of like building insurance of the occupant subsequently. As far as I'm aware, the issue around some of the issues around that relate to what data is available and where that data has been taken from. So it's limited, and there's a sort of natural sort of anxiety in the insurance industry around insuring mass timber. So that's holding us up. Again, that's not, it's quite a difficult one to sort of address comprehensively as part of a design team. But I think there is a conversation that needs to occur, and there needs to be a kind of a thorough and meaningful examination of what mass timber can offer the industry and offer us in facing a climate crisis. It's not something that we could. Well, there's certainly a kind of a potential for throwing baby out with the bathwater when it comes to how we build things and what we're making them out of.
And what about MMC in general? I mean, and I can see that there's a lot of arguments for saying, well, there should be far fewer faults and failings in the building, but that's logical. And unfortunately, the insurance industry isn't always logical. Do you see any resistance? Have you seen resistance with things like the fab houses?
There is, the insurers, obviously, if you've got a Victorian house that's was only designed to last sort of 50 or 100 years and it's still there, there's a lot more data around them than there is around factory built house, which has kind of just gone up. Bypass accreditation is really useful, like examining what sort of performance a building's got as it comes out of the factory is useful. There's a lot more records and accountability in terms of how it's gone together and what's been built, and certainly it's a far higher quality that's achieved than an on-site construction. So the reality is probably not quite the same as the perceived risk. But again, it's quite difficult to sort of manage that, or the insurance industry's kind of perception of it as a design team, as it were. But certainly, I think, if you're as a client looking at it, if you're a developer looking at it, then it is useful to sort of talk very openly and very early with, for example, mortgage providers or insurers who can come along on the journey from the outset and develop a position that's acceptable to everyone as a project finishes. But it does, I'd say the main thing about MMC kind of in inverted commas is that from our experience, it's more about process and than about one thing in particular, whether that's modular, panelized, or whatever it may be. And those 7 sort of different categories of MMC go right down to just how you do things on site, rather than building things completely in a factory. So there's a sort of need at the outset of project, I'd say, if you're interested in embracing MMC, to establish what the appropriate solution is for the project, and that will include questions around what sort of insurance risk looks like, or as a client and as an insurer, which might point in a different direction in terms of the MMC solution.
Well, I'm sorry that we've ended up talking about insurance. That's my fault. It's very important, but I think it's not the main thing, because what we have seen is such an amazing amount of positivity, so many opportunities and so many different ways of doing things. And I know there'll be a lot more in the future, and that probably all of you will be realizing the projects you've talked about and other projects on different ways. And hopefully everybody who's watching is going away with a lot of food for thought. As I said, I've really enjoyed this, and I think on behalf of Architecture Today and of our partner Schu, I just first of all want to thank the speakers, Tom Lewith, to thank Sasha Bhavan, Jonathan Green and Eva McNamara. And then just before we go, I just want to remind everybody who's watching that the Schu Excellence Awards are now open for entries. And these are awards that will recognise the best realised projects in a number of categories that have used windows and doors and facades from Schu, and they have had some fantastic winners in the past, and they're really worth entering. If you want to find out more, you can go to architecturetoday.co.uk /Schu-excellence-awards-2022. I'm sure you find your way through to that. You can see it up there on the screen. As I said, really worth doing. And I will look forward to seeing a lot of you, I hope, at the next event. And it's just the point to say goodbye and thank you very much indeed for watching. Bye.